Hello, this is Mr. Molo for lesson 9-1, identifying quadratic functions. Alright, so kind of a couple different things we're going to do today with the example problems. So we need to identify which functions are quadratics, find the domain and range, and then graph them. So a couple different things we're talking about, so some vocab we need to go over. So quadratic function, we'll go over what that means, parabola, vertex, minimum, maximum, all those words that might sound familiar, but kind of putting them all together. So a quadratic function has to be written in this form where it's a number. So remember, A, B, C are all variables, so they're going to be different numbers that change. So a number with x squared, and then a number with x, and then a number with c. The important part is that A can't be 0. Otherwise, if we pretty much eliminate, this part right here, well, then it's just a linear function. It's not a quadratic function. So A can't be 0. Otherwise, that kind of messes everything up. So then if A does end up being 0, we would just say, no, it's not a quadratic function. Vertex, so you know where the highest or lowest points of the parabola, so pretty much where that turns into a U, that, that bending point there. So one way to identify if it's a quadratic function is looking at it as a table. Okay, so we're looking to make sure that x's all go up by the same number, whether it's 1 or 2 or 3. And then with the y's, we're not looking to make sure that the y's go up by the same number, but that the difference of the y's are going up by the same number. So this is going up by 1, going up by 3, going up by 5, going up by 7. Well, from 1 to 3, 3 to 5, 5 to 7 is all a difference of 2. So we're looking at those second differences there for those kind of problems. Here's another example here, kind of the same thing, going up by 1 and then with differences of 2. Minimum and maximum, so this is what it's talking about when it says minimum and maximum. So the minimum here is going to be 0, because that's where the lowest point of it. Maximum here is going to be 5, that's the highest point of the graph. And then looking at the vertex, so where it bends, so -3, 0, and 3, 5. So looking at these, see if we can tell if it is quadratic. So looking at the x's, yes, they are all going down by 1, or up by 1 rather. And then the differences here, once we subtract them, you'll see the differences are all going to be the same. So from 39 to 18 is going to be a 21 difference. That's going to be a 15 difference. That's going to be a 9 difference. And that's going to be a 3 difference. But the difference between all these is going to be 6. So yes, that one is going to be a quadratic. Okay, the second one is going to be a no, because it doesn't have an x squared. So we would subtract 6x to make it say y equals, and it doesn't matter, there's no x squared. So this is going to be a linear equation if we wanted to graph this. So it's going to be a linear equation, not a quadratic. Here we do have an x squared, so this one would be a quadratic equation once we made it say y equals. So let's do one of these, for example, and graph it. So if this is my x and this is my y, I'm just going to pick some low numbers here, so like 0, 1, and -1. Okay, so then if I put in 0 there, x squared, so 0 squared is going to be 0. 0 times 4 is 0. If I put in 1, 1 squared is 1. 1 times 4 is 4. I put in -1 for my x. -1 times -1 is +1. 1 times 1 is 4. Oh, sorry, 4 times 1 is 4. So if I'm graphing that, I have a dot there. I have a dot at 1, 4, or -1, 4. 1, 2, 3, 4. And I have a dot at +1, 4. We'll see if we connect these dots right here. Kind of hard to do with the mouse, but we should get a parabola or a U shape. Okay. Another thing we're going to have to determine is whether it opens upward or downward. And the way we determine if it opens upward or downward is where it, or what A is. So remember that number in front of the x squared. So if it's going to be a greater than 0, it's going to open upward. If it's going to be less than 0, it's going to open downward. Okay, so this number right here. So for this slide, it's going to open downward for this one because it's a -3. So that means it's less than 0, so it's opening downward. This one is a +6, so it's going to be opening upward. This one is going to end up being +1, so it's going to open upward. And this one doesn't say y equals yet, so this one's kind of tricky. But once we make it say y equals, I would have subtracted 3x squared to both sides, which means it's going to be a -3x squared. So it's going to end up opening downward. Okay, so a couple different parts here. Identifying the minimum and the vertex. So like we talked about earlier, so the minimum is going to be that lowest point. So the lowest point here is a +2, and then that vertex is -3, 2. Highest point here is 5, vertex is 2, 5. So kind of looking at different problems like that to determine the minimum and the maximum. Talking about range and domain, domain and range. So domain, as long as it's quadratic, will be all real numbers, because every number would work, because you can put in any number you want for x, really. And then the range is going to be whatever number is bigger than that vertex or smaller than the vertex if it's opening downward. Okay, so like for this one, my domain, since it's quadratic, would be all real numbers. I could pick any number I wanted for x. My range would be all numbers greater than -4. So because -4 is the lowest, I know all of my ranges, all of my y numbers have to be bigger than -4. So domain, all real numbers. Range, all numbers greater than -4. For this one, again, domain is all real numbers. Any number would work since it's quadratic. My range is going to be all numbers less than 6. So you won't see any y's up here. When you plug in a number for this equation, will not be greater than 6. So that's why all the numbers in the range have to be less than 6.